Well, let's follow the money a little bit. This is where it's at right now. Okay. There is an argument I want to make at the theoretical level, and it's this. Think about you as a human. What powers your intelligence? Okay, I present to you a great big maze, and I say, find the optimal path from the start to the end. What happens in your brain? You kind of think, ugh, right? And then you start going through paths, and it's a hard problem. Okay, now suppose I come to a computer, and I say, okay, computer, here's a big, messy, complicated, two-dimensional maze. Find the shortest path from the start to the end. Go. What does it do?
Try them all.
Yeah, I mean, just do a depth first search. Just suddenly, bam, you found the optimal solution. Completely stomped the human. In other words, while statistics are cool, there's a right answer. And we even know the right answer. And pretty much computers can do it faster than humans can. And to a large extent, there's still lots of problems over here. I'm not trying to suggest that the whole decision-making side is a solved problem. But computers are friggin' fast, right? Back in, what was it, 1979, I think, when Deep Blue beat Kasparov at chess. Okay, that was a major turning point in AI because for a long time everybody said that, here, you're messing up my hierarchy too, go away. And you just go away because I bagged on you so much. There, now that's a little bit clean. And I'm going to scoot you over here just so that we have a nice tree structure. Okay. For a long time, people were saying, humans are the only real intelligence. Machines will never be there because chess. Well, ha ha ha. Now all of a sudden people had to say, oh, gee, you know, maybe computers are getting somewhere. But computers will never be as good as humans because, and then what did they pick?
Go.
Yeah, Go is the next obvious one. Well, we creamed Go. Go is an obvious choice because it's still down here in this decision-making branch, and it just had a bigger branching factor, and the speed of machines wasn't enough to fan out through it. But the thing is truth is, a lot of intelligent people are not real great at Go too. I mean, Go's an awesome game, but I don't think it really fully represents what intelligence is made of. There were a few branches on what people picked as the representative task of which humans' intelligence was good at. One of them was facial recognition. And not a bad choice because we have an entire region of our brain dedicated not just to vision. We have an actual lobe dedicated to recognizing faces. And this comes up when you, lobe might not have been the right term here. Neuroscientists would probably check me on that. But there are parts of your brain specifically dedicated to faces. And you know this because you look at a car and you see two headlights and it has a windshield and a bumper that's curved in some way. And what do you see? Totally a face, right? I mean, you all know that cars have faces. You've all seen the movie Cars. Okay. And it just feels like cars have faces. We like to find faces all over the place. If I just draw this, what is that? It's a face, right? Except it's totally not that does not look, I mean, let me put my face next to that. I mean, really, that's just not even like a face, but you find faces because you want to find faces. Now, of course, you've been trained to know that's a face, but I guess we could Google for, what's that word called, where you see faces in trees and clouds and dirt on the floor? Oh, that's fine. Let's see what happens. Okay. I could get in trouble if I do the wrong Google image search in class. Faces in things. Okay. Just looking at this, it just feels like is that not the happiest coffee mug you've ever seen? I mean, it's just like, yeah, that makes everybody feel good. But
It's almost like it's happening for
it is, it's creepy what this does to your mind, isn't it? But, I mean, you just can't just try looking at this page without anthropomorphizing any of these things. I mean, look at this zipper here. It's hilarious. And yet, that is so nothing like a face, right? Your mind just can't let it go because you know these things are faces. Okay. Wow, that is a hilarious purse. That cracks me up. Okay. Where was I? What does that have to do with my point? Stop distracting me. You guys are making me go off on tangents.
Humans are
Yeah. People pick facial recognition as a representative task of what machines would never beat humans at. Then machine learning got a bunch of money. Neural nets got deeper. Supervised deep neural networks have now outperformed humans at facial recognition. Not only facial recognition, they can do sign recognition and Chinese character recognition, and they've beat humans at all kinds of recognition tasks. And people are starting to realize, hey, our next representative task of what humans are better than machines at is getting lost. And to some people, that's sad because, hey, machines are getting better than us. We didn't beat humans at the perception side of things, the learning and understanding things, until a long time after we beat humans at the decision-making and planning side of things. I believe there's a reason for that, and one of those reasons is I think humans are darn good at learning and perceiving and understanding, and I don't think humans are really all that impressive at chess and Go and planning and maze running and decision-making and all these things. And by not impressive, I mean, yes, there are some darn good players. I could not beat Garry Kasparov and things like that, but hey, Deep Blue can. Or, of course, there's some debate, right? Have you heard the debate on Deep Blue? Apparently, there was a whole team of IBM researchers who were tuning Deep Blue while the game was in progress. So Kasparov argued, hey, I wasn't actually battling a machine, I was battling a team of humans. And of course, one human against a whole bunch of humans, which one's going to be better, right? So he says it was never even man versus machine. He says it was, and I don't know if that really represents his argument well. That's what somebody represented his argument as once. Is it? Okay, so, well, we've heard a couple witnesses on it, yeah.
Also admit on the recent TED talk that he said, after that I cannot argue anymore. Like that.
Okay, yeah. So if the guy continues to claim he won, well, let's just face it, he's going to get trounced. Modern computers have gotten yet faster. Moore's law has kept going for a while, and it's really speed, not intelligence, that allowed them to make decisions really effectively, right? Okay. Why are you effective at, say, babysitting? Or what's something you would not trust a machine with?
babysitting.
Driving a car, even? And we know we're getting there, right? That one makes us a little uncomfortable. Okay, I don't know. Well, the point is, now ask the question why. Is it because you think you're better than the machine at trying all the possible paths and picking the best one? Certainly not. Or is it because you kind of understand what's going on and the machine's just kind of oblivious? I think it's pretty clear that humans are just friggin' good over here and not so much over here, and therefore I argue that, well, focusing a little bit over here is going to be the way forward to helping strong AI emerge, and so that the system as a whole can exhibit great intelligence. Well, as deep learning has picked up and machine learning has really accelerated, this is where we're starting to see advancements being made that are bringing artificial intelligence forward. There's a lab at Berkeley right now that's working really hard on folding laundry. And I think that'll be a cool one because, you know, we all want a Rosie the housemaid that's going to make our home lives really convenient and easy, right? I feel like once we can fold laundry, that's a good step. Driving cars is another good one. But so the laundry folding lab is finding a lot of success with the combination of reinforcement and neural networks. Again, the reinforcement learning implies a bit of Markov decision processes. So there is a decision-making component, but there's also this learning priorities and dynamics and what's going on in the world. And when you bridge the two, that's when intelligence really kind of seems to emerge. Okay, all this was to justify the next module of this course. We've kind of looked over here and here a little bit. I want to give you a representative example of all of these three branches in this class. I'm going to claim we've done this one and filled it out a little bit. The next one I want to do is this branch, and after I'm done with it, we're going to do this one. And after we have discussed the three major components of machine learning, then I'm going to talk about how to put it together into a system that can make decisions and do good things in order to create intelligence. And that's kind of the structure of my course. So we've done this one. The next topic is supervised learning. The hottest topic in supervised learning these days is neural nets. We've already actually talked about them a little bit, except we did it over here. I could talk about neural nets in the supervised learning domain. I'm not going to. Here's why. It's a huge topic. It would dominate the entire rest of this class. I'm teaching a course on machine learning where I focus on neural networks just next semester. So if you want to hear it, take that class. And I'll spend the whole semester on this branch of the tree. Well, and other branches where neural nets plug in, which is all of them. I should do it here too. I meant for that to be black and thin. But what was I saying? Oh, so I picked a topic that would cover supervised learning and wouldn't take too long. I picked KNN models. Why? Because this is probably the simplest, easiest, least complex type of supervised learning model we can do. It's a representative sample of supervised learning, and if we cover this, it'll allow us to study one supervised learning mechanism in depth, and I don't think it'll take more than a week, because it's really, really fast, and then I can get on to other stuff. So don't think that KNN is necessarily the best supervised learning approach, because the best approach is neural nets. It just is. But I want to cover something in depth. Wise person once told me it's better to teach one thing well than lots of things poorly, and there's just no way I can cover neural nets. So we're going to do KNN for a little while, and then we'll say, great, you understand supervised learning. Then I'll talk a bit about some unsupervised techniques, and then we'll start putting them all together. Okay.